Okay, let's unpack something that's a little scary for a second. Imagine walking through a factory or even just a server room, and there's a threat in the air, something you can't see, but you really, really do not want to breathe.
Right. It's the kind of thing that keeps safety managers up at night. You can't just rely on your eyes or, frankly, even your nose to catch a gas leak before it's a real crisis.
Exactly. So today we're digging into one of those invisible hazards. I've got the data sheets here for the NTI E-H2S hydrogen sulfide detector. We're going to see what this one piece of hardware can tell us about safety infrastructure.
And this detector is a fascinating case study. It sits right at that intersection of, heavy industry and high-tech IT. Its mission is pretty straightforward. Protect the gear, and more importantly, protect the people.
So let's start with the villain here, the gas itself. We're talking about hydrogen sulfide, H2S.
H2S is nasty stuff. Most people know it from that rotten egg smell. But in an industrial setting, the smell is the least of your worries. It's corrosive, it's flammable, and it's very toxic.
And the documentation points to the usual places you'd find it, right?
The usual suspects. Paper mills, refineries, waste disposal sites, anywhere with heavy chemical processing.
That all makes sense. You picture a refinery, you expect gas detectors.
Yeah.
But one use case in these notes really jumped out at me. It says, failed UPS lead-acid batteries.
And that's the critical oversight so many people make.
We think of server rooms as these pristine, clean environments, not chemical hazard zones.
Exactly. But those uninterrupted power supplies are full of chemically active batteries. If a lead-acid battery fails, if it overcharges or gets too hot, it starts off gassing hydrogen sulfide.
Wow. So your clean room is suddenly filling with a gas that can kill your servers and you.
It destroys the electronics, and it can seriously injure anyone who walks in to check on an alarm.
That is a huge aha moment.
Yeah.
You don't just need this for a sewage plant. You might need it right next to your server rack. And looking at the specs, this thing is sensitive. It measures from 0 to 50 parts per million.
That range is very telling. To give you some context, OSHA's limit is around 10 to 20 ppm. At 50, you're looking at serious health effects.
So it's designed for early warning.
It's there to scream for help before you hit those dangerous legal and health limits, not after.
It's about catching the problem before it becomes a liability. Okay, so physically, looking at the diagrams, it's surprisingly small, about 4.5 inches wide.
Yeah, it mounts right onto a standard electrical box. It's infrastructure. You bolt it to the wall and ideally forget it's there until you need it.
But it's not a standalone gadget, is it? Looking at the schematic, it has to be wired into a main controller.
That's a key distinction. This is just the sensory endpoint, the nerve ending. It has to feed data back to one of NTI's main hubs, the E2D, 5D, or 16D units.
So those hubs are the brains.
They're the brains. They decide what to do with the information the sensor gathers.
Okay, but the sensor does have some autonomy, which I think is the smartest part of the design. It has a built-in 5A fan relay, an action feature.
Yes, and this is where it gets really interesting. This is where we move into automation. Because it has that relay, it can physically control things. Exhaust fans, valves, louvers, whatever you connect to it.
So if the H2S levels spike, it doesn't just send an alert.
It acts. It can automatically trigger the ventilation system to start clearing the room.
That automates the entire safety response. It doesn't wait for a human to see a light on a dashboard.
And that speed saves lives. In the time it takes for a person to even notice an alert, the gas concentration could double. By integrating the control right into the detector's loop, you cut the reaction time to almost zero.
When you think about that level of automation, the price tag starts to make a bit more sense. It's listed at $1,210.
It's a serious investment for sure. This is enterprise-grade equipment. There's a low-cost version for around $235, but for over $1,000, you're getting something hardened for industrial use.
The operating specs back that up too. It works from 0 all the way up to 125 degrees Fahrenheit.
Which covers you for those hot industrial zones, or even a failing server aisle that's overheating. It's versatile.
So when we put it all together, the key takeaway that this little box bridges the gap between just detecting a problem and actually starting to fix it.
It bridges detection and physical action, absolutely. It takes the burden of that immediate response off the human and puts it onto the hardware.
Which leaves us with a kind of provocative thought to end on then. If we're deploying tech that can sense a hazard and physically alter the environment to fix it, turning on fans, opening vents, are we getting to a point where our buildings are more responsible for our safety than we are?
It raises a really important question for future design. Is true safety just knowing a hazard exists? Or does it require the environment to automatically start healing itself before a person even has to step inside?
Something to think about. Thanks for listening, everyone.